Welcome to Big Data Testing tutorial on our BlissPass Academy's YouTube channel. We hope this content helps you elevate your skills and advance your career to the next level. Before you start the big data testing, you need to complete some topics. You need to know about the operating system. You need to know about the Linux commands. You need to know about the RDBMS. You need to know about the SQL. You also need to have a information about the data warehouse concepts, and you also should have a knowledge about software testing. You should also have a knowledge about ETL testing. And then you should also have a knowledge about big data foundations. Before you dive into big data testing course, you should at least know the basics of all these topics. Wondering how do you study this? Don't worry. We have a playlist for each of these topics. Please scan through those playlists and come back to the big data testing course. We always blend the concepts with the hands-on. Means we first cover the concepts, and wherever we have a hands-on, we complement the concepts with the hands-on. In order to perform the hands-on for the big data testing, we have done it on Cloudera and Snowflake. If you want to experience the big data testing hands-on, you got to install Cloudera and Snowflake. We do have required installation videos in our playlist. Please do refer that playlist and install the required environment. Anything else you need to know? Yes. Please do watch the complete playlist to enjoy the benefits of the course. But in case if you already know some of the topics, please skip those videos and scan through the subsequent videos. Please don't forget to subscribe to our channel and also share our channel with your friends and family. Thank you so much choosing BlissPass Academy. We are really excited to guide you on your big data testing.
Big data is a large amount of structured, unstructured, and semi-structured data that cannot be stored and processed by traditional relational database management systems. Now that we understood what is big data, can we trust complex operations like ingesting, transforming, storing massive volumes of the data across the big data systems are executed flawlessly? How do we ensure that ingesting, transforming, and storing the massive volumes of data are executed flawlessly? We'll ensure this through big data testing. So what is big data testing? Big data testing is a specialized form of testing that focuses on validating the accuracy, completeness, performance, and reliability of large and complex data sets and the associated processing pipelines within big data environment. Remember, we're not talking about small amount of data here. We are talking about large amount of data, potentially GB, potentially TB, potentially PB, that is petabytes, right? So through big data testing, we have to validate the accuracy, we have to validate the completeness, we have to validate the performance and reliability of large complex data sets and also associated processing pipelines. What is this associated processing pipelines? Big data processing, we do have different processes and systems which are piped together. They are series of processes and systems that handle the data from ingestion till the output. Processing pipelines would involve a lot of activities. Some of the important of them are data ingestion, data storage, data processing, and data visualization or data output. So when we talk about the big data processing pipelines, we have data from multiple sources that will be moved to the storage, big data storage like Hadoop and MongoDB, Cassandra, even cloud systems like Redis. And then that data would be subjected for processing through big data processing tools like Spark, Kafka, Flink. And then that will be stored in a different data warehouses. It can be Azure Data Lake. Within that, we have a dedicated SQL pool. Then we have SQL Server, Oracle, Snowflake. And then that data will be visualized through BI and reporting tools like Power BI and Tableau. So big data testing ensures the validation of the accuracy and completeness of the data from source till the BI and reporting tools. Okay, we understood what is big data testing, but why do we really need big data testing? Big data testing ensures the accuracy of the data processing and analysis under the varying loads. Like you have a data from 1 GB till the 1 petabytes, right? So whatever may be the load of the data, it ensures the data is accurate. Okay. Obviously, while we are performing the big data testing, the focus is on the data quality. If the quality of the data is not correct, then will not be able to take the correct management decisions. Then it guarantees the optimal performance and accurate results. Because if you don't do the big data testing, you may end up having issues in the future. That is the reason it ensures the optimal performance. And because we do that big data testing, we'll be able to detect the errors and inconsistencies pretty early in the project. That will help us to take the correct management systems. Okay. By performing the big data testing, we'll be able to scale the systems with a massive data volumes. Those who have been exposed to the ETL testing and trying to learn the big data testing now will have a question in their mind: how big data testing is different from ETL testing. Let us understand that at a high level. One of the very important aspect what we have to understand is big data testing in a way is an extension to the ETL testing, or it will be done in the similar way as that of ETL testing in terms of how you look at the validation and verification of the ETL processes. Everything would be similar. But some of the methodologies and foundational principles would differ in a subtle way. Let us understand them. First and foremost thing is, when we talk about the big data testing, focus is on the data quality of big data systems, which involve structured, unstructured, and semi-structured data. On the other hand, here we are mostly worried about the data warehousing in ETL testing. In big data testing, we'll have a testing of ingestion, storage, processing, quality, integration, governance, and data validation across the big data environments. On the other hand, when we talk about the data warehouse testing or ETL testing, it will primarily involve the ingestion, transformation, quality of the data warehouse systems. And in terms of data types, big data systems handle structured, semi-structured, and structured data. Obviously, you need to perform the validation of all these three types of data in big data testing. On the other hand, ETL testing primarily focuses on structured data. When I say ETL testing, I am referring in the context of the data warehouse testing or ETL testing done for the data warehouse. In terms of processing, it involves both the batch and real-time processing. On the other hand, data warehouse testing typically involves the batch processing. And in terms of infrastructure, we have different tools in big data like HDFS, MongoDB, Spark. So all the systems involved in storing and processing of the big data, we need to test that as a part of the big data testing. In case of data warehouse, it will be RDBMS systems and any data warehouse. Validation tools, we may involve like Spark, Kafka, HighQL, Python, and automation tools. On the other hand, in case of data warehouse, it will be mostly SQL-based tools, like it can be Informatica, it can be SSIS, it can be traditional automation tools. Complexity is definitely huge, or complexity is more in case of big data as compared to the data warehouse, right? Because of the volume, variety, velocity, and veracity, the complexity of the big data is much more as compared to the structured data stored in data warehouse. So in terms of skills, right? In case of ETL, you just need to know traditional ETL practices, data warehousing. Along with this, for a big data testers, you need to also know what is big data, what is distributed storage, what is distributed computing, what is distributed processing, and also different tools like HDFS, Hive, Spark, MongoDB, Cassandra. You should be exposed to all these tools. So, see, big data is emerged because of the velocity, veracity, volume of the data, isn't it? So, the systems like real-time systems, the data emanating from IoT systems. So, wherever the data is huge, we need to adopt the big data, and obviously wherever big data is adopted, we need to perform the big data testing. In case of common data warehouse systems, BI tools, and we are using the data warehouse for the historical data analysis. This is bit generic, may not be specific to the big data, but we want you to understand what are the different ways of processing the data. One is batch processing. Second one is a real-time processing. The third one is interactive processing. These are the different ways of data processing. You can process the data in batch. You can process the data in real time. You can process the data in an interactive manner. Let's understand them at a high level. Let's say batch processing, data is collected over a time and processed in bulk. That is the reason it is called as a batch processing. So it is often used in data warehousing, ETL systems, and also big data analytics. So what happens is, as I already indicated, application processes the data in batches, which is stored in HDFS in the context of the big data testing. So let us say sales data of any e-commerce company is aggregated, is accumulated over a period of time, like a week or fortnightly. If you're going to process a weekly data or the data which is accumulated over a period of time, then it is a batch processing. When we talk about the batch processing, obviously we need to validate that batch data processing, right? So in the batch data processing, we'll verify large volumes of the data, whether integrity, the quality of the data is fine or not, performance is fine or not, accuracy and completeness of the data is fine or not. Okay. So let us say if a data is stored in HDFS, we'll go ahead and check whether the data is complete, whether the data is accurate, and how the reports are being generated from that. Okay. Shifting our focus to the real-time data processing. A real-time data processing is processing of the data as and when the data is produced. Other way of putting it here is real-time processing, immediate processing of data as when it is received with the minimal latency. What is latency? Latency is delay with minimal delay, right? So the system processes the input data and delivers the result almost instantaneously. I'm saying almost instantaneously, right? That is the real-time processing. So let us say the data is being produced by IoT devices, or as and when the customers are purchasing the equities in a real time, the analysis has to happen in real time, and the result needs to be updated in the stock trading systems. When we talk about the real-time data testing, we got to validate the accuracy here. We got to validate the completeness. Along with that, we also need to know the response time of the validations, response time of the processing. We have to validate that aspect as well when we talk about the real-time data processing. So interactive processing, as the name suggests, the processing is happening in an interactive manner. So in the interactive processing, systems takes the user inputs and responds to the user in real time. As and when user is giving the input to the system is responding to that immediately. See, there is a difference between real-time processing and interactive processing. In real-time processing, as and when the data is produced, the processing is happening. But in case of interactive processing, there is always a customer or a user involved here. That is the reason it is called as interactive. The user is going to give some input, the system has to respond. Based on that response, user is going to give one input. Based on that, system is going to give a response. Based on the response, user is going to give another input. Based on that input, system is going to respond. This will continue until the processing completes. That is what is interactive processing is. So, like you can have online banking applications and e-commerce websites. In these systems, the processing happens in an interactive manner. If you want to look at the interactive processing testing, right, we have to simulate the same thing. Like user is going to give an input and there is a response. Based on the response, we have to give another input, how the system is behaving in that way. This may not be directly related to the big data testing, but this is one way of processing, that is interactive processing. That is the reason you need to know about interactive processing. So here the focus is on definitely the accuracy and completeness along with that responsiveness, performance of the data. How soon system is able to respond to the user inputs. That will be tested here. So for example, in a banking application, the user, as soon as user gives a user ID and password, it should log in. If a user clicks on the account balance, it should display. Like that, depending upon the user input, system should respond quickly. What is batch processing? What is real-time processing? What is interactive processing? Let us spend some time on how batch, interactive, and real-time processing are different. Okay. The focus in the batch processing is processing the large volumes of the data. In the interactive processing, fast response to the direct user input. In the real-time processing, it is a continuous processing. As and when the data is getting produced, it is a continuous processing. In case of user interaction, because it is a batch processing where the data is already collected and kept, there is no user interaction here. In case of interactive processing, there is a direct involvement of the user because user is there. He is providing the input based on the response. In case of real-time processing, either no user interaction or there will be very, very minimal user interaction. Response time in batch processing, it may take minutes to hours as the data is huge and there is no urgency. In case of interactive processing, there is a quick response. In real-time processing, because you need to take the decision based on the processing of the data, the time constraints are very, very strict. So in batch processing, it's like a payroll processing and processing a large amount of data which is accumulated over a period of time. In case of interactive processing, like user is trying to query the account balance in his bank account. And in case of real-time processing, the stock data. And as and when the sensor data is being collected, how do you predict the weather? So processing of the real-time stock market. That is one of the examples for the real-time processing. So here the focus of the testing is accuracy, completeness, and performance of the batch jobs. Here in interactive processing, UI responsiveness as user is there. Okay. Here the real-time data accuracy and also system performance. In case of batch processing, data warehousing, payroll systems, reporting systems. In case of interactive processing, it will be websites, apps, online forms. In case of real-time processing, financial trading, IoT systems, live monitoring. And tools, you have Apache, Hadoop, Informatica, Talent, Databricks, all those tools or components are used in batch processing. In case of interactive processing testing, we'll use Selenium, JMeter, Unified Functional Testing, UFT tools. In case of real-time processing, use Apache Kafka, Apache Storm, Splunk, Spark, and all those things. At a high level, the big data testing can be classified into functional testing and non-functional testing. In functional testing, we do the testing through different stages like data ingestion testing, data storage testing, data processing testing, and also data visualization testing. So across all the different stages, we perform the big data testing. And on the non-functional testing, there are different types. One is you can perform the infrastructure testing. We can perform the big data application setup testing. We can perform the performance testing to know the performance of the data pipelines. And we can perform the data security testing. We can also perform the failover recovery testing. What is big data testing? Then we also understood big data testing classifications. Then how do we proceed now? What needs to be done? Let us discuss that. First and foremost thing in a big data engineering project, as a tester, you need to understand the requirement. How does the requirement look like? Let us understand that business requirements are specified in different formats. One is business requirement document, as indicated here. And also there is something called SRS, software requirement specification. And these days we also get the requirements in user stories. So when we talk about any software engineering project, either in the form of business requirement document or software requirement specification or user stories or one more thing called PRD, that is product requirement document. One of these formats will get the requirements. In case of big data, how does the requirement look like? All these requirement documents would describe what is the need of this project, what is the objective of this project would be defined. So while performing the big data testing, we have to go through certain business requirement documents. What are they? First and foremost thing is big data requirement document, that will be in the form of business requirement document or PRD or user stories. Then we also need to understand mapping document or mapping sheets. We also need to understand schema of a source and target. So from the perspective of the big data testing, we got to understand the big data requirement document, mapping sheets, schema of the source, and target. So from the perspective of the big data testing, we got to understand the big data requirement document, mapping sheets, schema of the source, and target. What is BRD? At a high level, BRD, that is big data requirements document, it will outline the requirements for the big data, like what are the identifiers, the descriptions, categories, source and target systems. It will also provide you the checklist. What would be the acceptance criteria? What would be the success criteria? What are the different priority levels to ensure effective testing? All those things would be provided in case of big data requirement document. And in case of mapping sheets, it provides a record of transformations between the source and target systems. In case of schema of source and target, it contains the structure of the source and target tables. Let us understand them in bit more detail. So when we talk about the big data requirement document, it will include the requirement heading. Remember, we are specifying in one of the generic format of these documents. Depending upon the project, depending upon the company, these formats may differ, but the core of the requirements would remain same or similar. Now, in case of big data requirement document, we have unique identifier ID, then we would have a requirement description, then category of is the requirement in the ingestion, storage, or processing, and then source system. What is the source system for this particular requirement, and what is the target system? And also it specify what are the different things we have to check during the each stage of the data pipeline. And then importance level, what is the high, medium, low of the requirements. Based on that, you can focus on the test. And also it provides the acceptance criteria or a success criteria. One of the sample big data requirement document would look like this. As I already indicated, the format may differ. In this case, we are specifying it in a Excel format, but you may get this in a document format. But if you see, we have a requirement ID, requirement description, category, is it a data addition storage, and we have a source system, target system. Source is the data from which the data is passed on, and target where the data is loaded into, and what are the different validations which you have to check, and what is the acceptance criteria, is the priority high, and if there are any other nodes. This is how sample big data requirement document would look like. Then the mapping document is also one of the very, very important document for any of the data engineering project. It can be big data engineering, it can be common data engineering, any of the data engineering project. So it would include transformation ID, unique identifier for mapping or a transformation role, and description. What is this transformation about? And then source table name of the table from which the data originates. And then we have target table name of the table or a system to which the data is loaded. That is a target. Depending upon the stage at which the source and target may differ. Source field name, what is the field name? See, we are looking at the tables here. Right? Within the tables, we may have some 10 fields, 10 columns. Those are also mentioned. What is the target field name? And transformation logic. Is it a aggregation? Is it a filtering? Is it a converting a higher case into lower case? All those aspects should be mentioned as a part of the transformation logic. And what is the testing scenario, which will be mostly specified by the testing team. The sample mapping sheet would look like this. As I said, transformation ID, description. What are you trying to do? What is the name of the source table? What is the name of the target table? Target, this is a target here. And source field name, target field name. This source field name is from the source table. Target field name is from the target table. What is the transformation logic and what is the validation scenario? Then we also have a schema of a source and target. See, before we load the data into the target, you need to create the structure of a table, right? In that case, we do have different sources and targets, like name of all the tables in both source and target databases, and also column names. What are the columns in these tables? That would be there. We have data types for each field. Is it a int? Is it a varchar? Is it a date? Each field for all the columns, for all the tables. That would be there. And we have a, which would be the primary key, so that there is no confusion. Amongst the fields which are there here, which one should be the primary key would be indicated. And which would be the foreign key. If there is any relation between the two tables, which key should act as a foreign key, that also will be indicated. And constraints, if there are any constraints, primary key constraint, not all constraint, unique constraint, check constraints, that also will be specified. And what are the default values? Like for example, date. The date is not specified, you should take the current date, like that. And relationships, how the tables are related. So these are the different aspects mentioned in the schema of a source and also target. They will also mention about the schema of namespaces, if there is any logical grouping of the table. So this is how a sample of a schema of a source and target would look like. You can see this is the table name here. This table includes these fields, customer ID, customer name, these fields, and this field is of this data type, int, varchar, and all those things. So this is the primary key for this particular table, and not null is a constraint. So the same would go for target schemas. Big data testing lifecycle involves different phases of testing aligned to the big data development. When you have to test the big data development project, what are all the activities you need to perform from the big data testing lifecycle? Big data testing lifecycle involves 4 important phases: requirement analysis, test planning, test preparation, and test execution. So when we talk about any software development, we do have a requirement analysis as a part of that. The requirements are defined by business analysts or the owners of the application. Requirements can be defined as SRS, that is software requirement specification, PRD, that is product requirement documents. These days, because of the agile methodologies, we also call requirements as a user stories. While the requirement document should be similar in most of the different software projects, there is a subtle variation in case of big data projects. When we talk about the requirements in big data projects, our focus is more or less around the data. Where is the data being sent to? So we got to study the source and targets. Like, what are our source systems? Is it coming from RDBMS? Is it coming from applications? Is it coming from a files? And what are our target systems? Where are we sending this data to? Are we sending this data to data warehouse? Are we funneling this data to the machine learning algorithms like that? And data production processes. So we also need to understand what is the mapping between the source and target, including various data formats. Is it a CSV? Is it a JSON? Or what kind of a data format? What is the volume of the data we are speaking about? What is the frequency at which the data is being sent from source to target after the transformation is done? Right? All these come under the requirements of big data project or any data engineering project. So once we understand the source and target, we also understand how is the data integration being done from source to target. Like, examine how different sources will be integrated, including extraction, transformation, loading processes. What are the different transformation rules? Is it a basic conversion? Is it an aggregation? And any, how are they cleaning the data? Those aspects also need to be understood. So as a part of the ETL, first and foremost thing is we are extracting the data. What are the different extraction techniques are involved in this whole project? Like, what are the processing frameworks? Are we using Spark? Are we using Hive? Are we using Snowflake? Which kind of a framework is being used? What is the transformation rules or a transformation logic? So all these are defined in the requirements of a big data project. We need to analyze them as a tester. Then we also need to know technology components. Like I already indicated, do we working in a Hadoop environment? Do we have a Spark or a Flink or a Kafka? Where do we have a storage? Because we also need to analyze where the data is stored. Is the data stored in HDFS or NoSQL systems like MongoDB, HBase, right? Once we understand source and target, once we understand the integration of source and target and different aspects of the technology components and storage requirements, by analyzing all these things, we got to define the use cases in scope. See, use case is different from test case. We got to define the use cases in scope. So these use cases would focus on data processing workflows, analytics, and reporting requirements for project. Planning is one of the important phases of big data testing, where you will go ahead and identify the key components and select the tools and also develop the strategy. Like in the requirements analysis, what you would have done is you would have scanned through the requirement, understood what are the sources and targets, and understood what are the ETL processes. Now, within that, we have to choose which are the critical components as per the scope of this particular project. Which are the components which requires the testing, such as which data pipeline, where do I need to focus, what are the processing rules, what are the transformation logic, that need to be precisely pinned down in test planning phase. And then again, in the requirements, we would know all the components. But here, from the testing perspective, What are the automation tools I have to use? What are the scheduling tools I have to use from the testing perspective? That need to be determined. Once you determine all these things, you have to develop the test strategy. That would involve various things like what is our testing approach in this project? What are the methodologies? What are the metrics we are going to capture and report? And what is the success criteria? What is the entry criteria? All those things need to be captured as a part of the test strategy. And also, you should know whether are you doing the report testing or not. What are the different types of testing you are trying to do? Like, are you doing a functional testing? Are you doing a non-functional testing? Within non-functional testing, are you doing a security testing? So all those types of testing methodologies, metrics need to be pinned down and documented in a document. We understood what is test planning. In the test planning, we'll only analyze and plan for the testing. In case of preparation, we will go down and document the test cases, exact test cases, and we'll look at the environment, we'll prepare the data, we'll look at the various aspects of the access. So when we talk about the test preparation, one of the important thing what we will do in test preparation is documenting the detailed steps of how are we going to test. That is creating the test cases. Okay. So we will develop the detailed test cases that cover all the aspects of the ingestion, processing, output validation, and from where to where. Third, the data is going from which source to which target. We'll cover all the source and target. That is the first and foremost thing what we do. And then we'll also focus on what is the environment needed to perform this test. Either we as a testing team will try to configure the test environment or will raise a request to the infrastructure team. Hey guys, we would need this particular environment for testing. Please ensure that this gets done before we start our testing. Like in terms of environment setup, it should closely mirror the production setup. And as I said, we will be collaborating with the infrastructure team to create the environment team. Especially in the case of big data, we'll try to see if we can optimize the clusters by ensuring proper data configurations. And without the test data, how can we test? This is also one of the important activity in case of test preparation. In case of testing, we'll try to mimic the real world test data. In case of ETL testing or a big data testing, we'll be already having a data of some billions of records in the production environment. We'll see how do you try to get the subset of that data and do the testing. We also would document the testing processes. How do we configure a particular setup? And if in case if we find the defect, what should we do about it? Whom we should be assigning the defect? All those processes are documented. Doing the whole testing, right? Would be having multiple team members, and multiple team members would require the control at various levels. So we would also raise that particular what kind of access is needed for different team members for a testing environment. And we would emphasize on how do we monitor, how do we log. We'll also configure the monitoring tools and logging mechanism to track the performance of the system and how the data is flowing from one system to another systems. And if we find any errors, how do we tackle them? In case if it is a report testing, then we also have to look at additional steps. Like how do you check the accuracy of the data reflected in the reports? Okay, you have a data in data warehouse. How is that getting reflected in the reports? That also is an additional step. So one more important thing in the report testing is the layout. For example, what should be the layout? So far, in the big data testing lifecycle, we understood requirements, we understood planning, and also we understood preparation. Why are we doing all these things? To execute the test cases and find out whether the data pipelines are built as per the requirement or not, whether the data pipelines are performing the right transformations or not. All those things would be carried out in test execution, like performing the smoke testing and capturing and analyzing the test results and preparing the summary report, logging the defects. All those things will be carried out in the test execution. When you start the test execution, the first and foremost thing would be a smoke testing. In the smoke testing, we would run preliminary tests to ensure if all the essential big data functions are operational, whether the files which are need to be ingested are they being ingested or not. At a high level, if the data pipelines which are built are ready to be tested or not, that would be validated in the smoke testing. Once smoke testing passes, we'll perform the functional testing by executing all the prepared test cases against the data pipelines in a big data environment. And if there are any defects, we'll log them in a defect management tool. Then once we perform the test execution, we'll see, hey, how many of them have passed? How many of them have failed? So in the process, we'll see if there are any patterns or anomalies, if there are any areas of improvement we have to do while doing the test execution. After analyzing the reports, we'll prepare the comprehensive summary report detailing out testing outcomes, like how many test cases are executed, how many of them have passed, how many of them have failed, what are the number of defects, how many of them are open, how many of them are closed. All those things would be there as a part of the test summary report. So we log the defects. Why? We log the defects to say the system is not really working as it is intended to do so. So you have to manage the defects, you have to track and prioritize the defects, the resolution, ensuring the communication is done with the development teams. Like if you log some 1,000 defects, all of them cannot be fixed in the same release. Some of them have to be carried out to the next release. That is where prioritization comes into picture. Once you fix the defects and deploy them into the system, then you should ensure that fixes are effective and no new issues have been introduced to the existing system. That would be performed as a part of the regression testing. So in case of report testing, we have to conduct the smoke testing to ensure reporting tool is connected to the correct data sources or not. That is another important. If it is not connected to the correct data sources, then obviously it will spit out the report with the errors and then execute the documented test cases and report the results. In the end, you also have to validate the data. What is there on the report and what is there in the system in data warehouse. That also need to be validated as a part of the report testing. We understood different phases of big data testing lifecycle. So what next? The different big data testing lifecycle phases involve requirement analysis, test planning, test preparation, and also test execution. So one of the important phase is test preparation, where we document the test cases. We document the test cases, isn't it? In order to write a test case, you also need to know what are the important validations which are performed in big data testing. So what are those? What are those validations? First of all, when you say important validations, what do I mean by that? When you say validation, data validations, remember, our focus is on the data here because we are in a big data testing. Data validation tests ensure that the data is present in the target systems. First of all, data is present, and whatever the data is present, that should be valid, accurate. and there should not be any loss of the data, and there should not be any discrepancies. It should be as per the mapping document. It should be as per the requirement document, so that that can be further used in the production system. That is a data validation. We do have different types of data validation. One is mapping document validation. The second one is the metadata check. Third one is data mismatch check. So overall testing validations in the big data can be classified into mapping document validation, metadata check, data mismatch check. Let us look at them at a high level. When we talk about the data mismatch check, we'll have different ways to do that. One is we have to focus on the data quality, and we have to focus on the validation of transformation. We have to focus on the data validation itself. Then when we talk about the data quality, which is the most important aspect of the whole data project, we have to verify completeness. We have to verify accuracy or correctness. We have to verify the data consistency. Just to recollect, in the previous video, we understood the different types of validations in big data testing. Now, as a part of this video, we'll understand the requirement document validation. When you are coming out with the requirements for the big data, you're bound to have some issues, right? Like there may be some errors in mapping, there may be some data quality issues, there may be transformation errors, and schema matches are not done properly, and there may be issues on the data integrity. So by conducting the thorough requirement validation, we'll be able to see if there are any errors. If we do the requirement document validation, we'll be able to catch all the potential errors very early in the development life cycle. That will make our project more successful. We do have different requirement document validations. Like we will be looking at whether the requirement is complete or not through requirement completeness check. Then we'll also check data mapping verification. We will check schema and metadata validation. We'll check ingestion, processing, and storage check. And we'll also check reporting and output. We understood there are few types of requirement document validation like completeness, data mapping, schema and metadata, ingestion, processing and storage, reporting, and output. So what is requirement completeness and why do we need to do that? And we talk about the data engineering projects. As you know, it involves get the data from source to the target. Now, when we are trying to get the data from source to target after applying all the transformations, as a part of the requirement completeness check, we'll verify that all the sources and targets are fine or not. Have they mentioned all the appropriate sources and targets? And the transformation, all the processing requirements, are they properly documented or not? Now, the question may be, how will you validate that? So let us say they have mentioned some 10 sources and some 10 targets. And then there may be a possibility that they would not mention the couple of data sources. They would not mention the couple of targets. You have to ask the business analyst or a person who is responsible for specifying the requirements. Like this, we will validate whether the requirement is complete or not. Then comes the data mapping verification. So we may say all of these things come as a part of the requirements only. But some of this needs a special mention because core of the big data engineering projects would involve this data mapping, and we have to ensure the data mapping is proper. Data mapping involves accurately mapping the source attributes to the target attributes, including transformations. So that if you have not mentioned the source attributes like source columns, source fields, and how are they getting transformed into, then obviously there is an issue with the data mapping, and that need to be highlighted well in advance. Then comes the schema and metadata validation. So when we have a source, where is the data stored in? Data is stored in a source table, and data is getting loaded into the target table. When I say table, it should have a schema, isn't it? So if they have mentioned some 5 attributes in source, and if they have mentioned 5 attributes, if there is transformation involved and there is a one-to-one mapping is there, then the schema should contain these 5 attributes, and the schema and the target should contain these 5 attributes. So like that, you have to go on critically verifying whether the schema is provided for all the mentioned tables or not. Okay, you have to check how many fields are there. You have to check what is the data type mentioned in the source, what is the data type mentioned in the target. If there is any issue, you have to highlight that. Then ingestion, processing, and storage requirements. So the data is on the move. Whenever we talk about a data engineering project, the data is on the move. Source, then staging, then target. Target can be data warehouse, it can be MongoDB, it can be any other target. So whether the data is ingested properly or not, whatever the specifications required for the data ingestion, is it mentioned properly or not, that need to be validated in the requirements document validation. Then comes the reporting and output. So remember, we are not validating the report from the test execution perspective. We are validating that from the requirements, whether the requirements are specified properly or not. That is what we are validating. So the execution comes after we write the test cases and after the data migration, data transformation is done. But we are trying to do all these validations much advanced in the project. So in the reporting, we'll see whether the output formats are mentioned properly or not. So what are the different computation mentioned, whether they are making sense or not. All those things need to be validated in the reporting and output. We understood there are 3 important types of big data testing validations. They are mapping document validation, metadata check, and also data mismatch check. If you recollect, in the previous videos, we have completed the mapping document validation. Now, the focus is on metadata. What is metadata? We already know it, right? But for the revision, metadata is the data about data. And don't say it is a data itself. Metadata is the data about data. It is a summarized data for the contextual data. We are summarizing the whole data itself. So if you are not validating the metadata, then the data itself may go wrong. Metadata check is one of the important aspects of the whole big data engineering. So metadata in big data refers to the information about the data such as data types, field names, schema structure, data source, and lineage. We have to validate the metadata to have a consistency and also integrity as the data flow from various stages of the big data pipeline. Metadata check usually involves verifying the accuracy of table definitions against the mapping document supplied as a part of the requirements. And then we compare the table and column metadata across the different environments in big data, so that if there are any changes, they are applied appropriately. In metadata check, this is one of the example of metadata. This is a metadata of a table called customer. For a customer, we have customer ID as a field, which is nothing but a column name, customer name, city, grade, and sales. Customer ID happens to be in type and no null values are allowed here, and this happens to be a primary key. Default is null value allowed, but here we are saying no null values allowed. It is a kind of a constraint. Okay. In the similar way, for each of the fields, for each of the columns, data type is specified, constraints are specified. That is what we have to check. At a high level, metadata check is done by 3 steps. One is data type check, the second one is data length check, and the third one is constraint check. What is data type check? As the name suggests, the data type check involves verifying the source and target data types. And also, what are the table definitions? When I say table definitions, it involves multiple things like what are the fields or columns and what is the source, what is the target, all those aspects which are mentioned in the mapping document. There is a possibility that the target data type is different than the one which is mentioned in the mapping document. There is a possibility that source data type is different the one which is mentioned in the mapping document. So at the end of the day, we are validating the metadata as against the mapping document. Then comes the data length. What length we are talking about here? We are talking about a data length here, isn't it? When I say data length, it is nothing but how many characters are allowed in a field. When I say a field, I'm talking about a column again. As we have seen an example in the customer table earlier, so customer name, it should be only 20 characters. Like that, the data length is also specified as a part of the mapping document. As a part of the data length check, we will verify the length of the database columns are as per the requirement document. And also, length of the target column data type should be equal or greater than the source column data type, which is usually specified as a part of the mapping document. Apart from the type check and the length check, we also need to validate the constraints which are mentioned as a part of the mapping document. We have covered what are the constraints as a part of the earlier videos. If you want to check, please check our videos on the constraints. Constraints are specific conditions that help us to maintain the data integrity while inserting the data, updating the data, and deleting the data. As a part of the constraint check, we will verify the index values and also constraints as per the specification document. Assume we are saying, let us say customer ID. Customer ID, we can say not null. That is a not null constraint. We'll see whether it is properly updated or not. Okay. So some of the other examples of the constraints are primary key constraint, foreign key constraint, not null constraint. Anyway, we discussed requirements document validation and metadata validation. So what next? That is going to be data mismatch check. So when we talk about the big data testing, as you know, data mismatch check in testing is the validation that identify and resolve any inconsistencies between the source and target. By performing the data mismatch check, data consistency across ingestion, storage, and transformation stages is ensured. How are we ensuring the data consistency across these stages? By validating the accurate data is ingested and it is stored at the right place and all the applicable transformations are applied or validated in data mismatch check. At a high level, in a data mismatch check, we do have data quality, as one of the type, and we have data transformation validation, and we have one-on-one data validation. So depending upon different scenarios, depending upon different places, people do classify them in a different ways. This is one of the classification which we have done based on our experience in the data engineering and data test. When I say data quality, what is data quality testing? Data quality testing verifies if the data meets predefined standards for accuracy, completeness, consistency, and integrity. We can look at further in a simple terms. Data quality testing checks if the data is clean, reliable, and fits the quality criteria necessary for the business or analytical use. This is one of the important things. The quality of the data may differ from one business to another business, one usage to another usage. Some of the aspects which will validate are there any missing or invalid entries? That comes under the data quality. Is the data consistent across the different data assets? Does the data adhere to the integrity rules defined as a part of the requirements document? So in data quality, we do have different dimensions like data completeness, data accuracy or correctness, data consistency. As a part of the data quality, we need to check the data completeness, data accuracy, data consistency. So we'll move forward to understand what is data completeness. We are trying to understand the big data testing. Completeness check is very important dimension of data quality. As a part of the completeness, we will ensure that the data which is ingested, stored, and processed is complete and nothing is missing. Nothing is missing which was supposed to be there in the table of a database or in a file. Especially when we are talking about the big data environments, we are talking about the vast amount of data which is spread across different systems in a distributed system. So you have to ensure the data is complete in all the systems which is distributed across different systems in a cluster. So take an example. As a part of the data completeness check, we'll see if there are any missing values. So that means if there is a missing value, then the data is not complete, right? And also we'll check whether if there are any duplicate values. So this duplicate value check can be considered as a part of the completeness check and also can be considered as a part of the accuracy check. As a part of the completeness check, will ensure that all the required data is present and accurately captured in a data set. Data set can be a table or a file or a HDFS, any of the systems. Data completeness check also validates none of the essential information is missing across the specified fields or records. It ensures the data integrity as per the specified business rules and requirements. As a part of the completeness check, will also ensure the data is loaded or migrated without compromising the quality and reliability of the data. All of this would be checked or validated through completeness check. We do have different types of completeness check, and they are: one is record count check, the second one is column data profiling, the third one is data duplication check. Record count check is a part of data completeness check. Means essentially by doing the record count, you are ensuring your data is complete. If I ask you a question, when we are working in big data, do you think everything will go as expected? Everything will be hunky dory? Not really. When you are building the big data pipelines, there are chances that some of the data, some of the records may be dropped, some of the records may be duplicated, or some of the records may be improperly loaded across the different nodes in a cluster. So, as a part of the big data testing, record count check is very, very important. Through that, will ensure the data is complete across the ingestion, storage, and transformation processes. By verifying the record count matches between the source and target systems, we will identify if there are any discrepancies so that data integrity is maintained, which in turn will ensure the downstream applications are consuming the right data at the right time. Some of the important aspects of the record count check are, first and foremost thing is, record count check only checks the count. It doesn't involve checking the values of the data in the tables. Don't mistake the record count check checking the values. Means, let us say we have source has 5 values, 1, 2, 3, 4, 5, and target has, let us say, 1, 2, 3, 5. Okay. Record count check will only check source has 5 values, target has 4 values. It doesn't check whether 1 is there or 2 is there. That's what I mean by this. So when you are doing the record count check, it is an initial validation. We are not really looking for in-depth data quality checks. That is the reason a record count check will be done as a first step. As I already indicated, a record count check involves comparing and validating the count of records of the source and target tables. And also, record count check will not really worry about whether the value in a source table is ascending or descending, or whether the value in a target table is in ascending or descending. The primary goal, the focus is on record count. It is only focused on count rather than anything else. So how do we go about doing it on the ground? So you will have a hands-on for this. What you will do is you will try to write a SQL query, select count star from a source table, and compare that with the select count star from a target table. Either you can use a minus query or a query depending upon which RDBMS system you are using.
We'll go through the hands-on session on data completeness check. I've logged into my Snowflake account. Please click on this plus button in the left corner and select SQL worksheet. I got the new worksheet. So to get started, we'll create required tables. So before that, we'll create the database, create database called testing. Let me run this by clicking this button in the right corner. So database testing is successfully created. Next, I'll use this database. Then let me create tables. The first table which I'm going to create is table employee data source, in which I have 9 columns. Let me create this. I just created the table. Let me insert some data into it. I'm trying to insert some 11 rows. Just run this. So it's showing number of rows inserted are 11. So let us see how the data is inserted in the table, employee data source. So the data has been inserted. So all the 11 rows have been inserted. Let me create one more table, employee data target table. This also has some around 9 columns. Let me create this. So let me insert some values to this target table, employee data target. Here also I'm inserting some 11 records into the table. Yes, it is successfully done. So let me check how the data looks in this table. Select star from employee data target. The data looks fine. 11 rows are inserted in the table. You could observe there is some transformation from source to target in this table, right? So the data set is ready now. So let's begin with all the data completeness check validation. The first check which comes in, data completeness check, is count check. So for this, let's check what is the count of source table and what is the count of target table and whether they are matching. Yes, let me check the source table count. Yes, it is 11 records. Let me check the count in the target table. That also is 11. And according to a mapping document, the record count is 11, which matches, and there is no discrepancies here. So there is no error. The source data count and the target data count is matching. That means the data is complete in both source and target tables.
Okay, we are trying to understand the column data profiling as a part of the big data testing, as a part of the data completeness. So what is column data profiling? What exactly is a column data profiling? Column data profiling is the process of examining individual columns within the large data sets to see and understand the characteristics or patterns and the quality of the data that exists in those columns. As a part of the column data profiling, we'll understand what are the data types in that particular column. How is the distribution of the data? Are there any missing values? Are there any outliers? And is there any different pattern emerging by analyzing this data? Are there any patterns across the vast volumes of the data? By looking at the profile of a column, in a way, we'll understand what is the quality of the data. In column data profiling, we'll compare the source and target data without actually comparing the entire data. What do we do then? What we'll do is we'll create the logical sets or subgroups from the whole data set and reduce the number of records from the bigger group, and then do a comparison between the source and target. Then the question would be, why do we really need to do only the comparison of the subgroups or a logical sets? That is because when you are trying to understand the data as a whole, you would potentially have billions of records. So you will not be able to go and check each and every record. That is where through column data profiling, we will understand the pattern, we'll get to know the quality of the data. So it is essential for us to do the column data profiling when we are testing the large amounts of data. Column data profiling involves four important aspects. One is data type analysis. The second one is value distribution. The third one is null and missing value assessment. The last one is statistical summary. Let us look at them one by one. As a part of the data type analysis, as the name suggests, in the data type analysis, we'll analyze the data types. We'll evaluate whether the values in each column conform to the expected data types as per the mapping document. Means in your mapping document, it is a particular column is suggested as an integer. Do you have that particular column as an integer? Do you have a particular column as a string? So if there are any inconsistencies between whatever you are finding out as compared to the requirement document or mapping document, you will flag that. Value distribution is one of the important aspects of the column data profiling. What will we do as a part of the value distribution? We would analyze how many number of times a particular value is repeated. Means, are there any unique values? What is the range between the values in a particular column? For example, you have some 2000 as the highest value and you have 1 as a lowest value. The range is 1999, right? So like that, we'll identify what is the range? Are there any outliers? Okay, so you have a column where you have some 1,000 values. Within that, one value is around $10 million, but all other values are in the average of $1,000. Then it is an outlier. So as a part of the value distribution, we'll analyze the frequency of unique values, we'll understand the patterns, we'll see what are the ranges, and we'll try to look for any outliers in the data. And when you have a data, can you have a data without null values and missing values? Most of the data would have null and missing values. Okay. So as a part of column data profiling, we'll understand how many null values are there, how many missing values are there as compared to the whole data set. This will help us to determine the data completeness and identify the areas that require cleansing and also additional data collection. Means if there are any missing values, we need to know how to fill them up, right? For that, we'll also know what would be the effort for a additional data collection. The last one is statistical summary. As a part of the column profiling, it generates the statistics like mean of the data, median of the data, standard deviation of the data, range of the data. By analyzing the mean, median, mode, standard deviation, we'll understand the overall distribution and also central tendency of the data within that column. For an example here, let us say you have an employee table, right? You have an employee table with different columns. What we can do is, if you go ahead and profile the results on a whole table, you have overall 11 records are there. Number of unique values here, considering all the columns, is 11. And number of blanks is 3. In this case, you have 3 here, right? And sum of the salary would be some 477K. Like this, you will understand this table at a high level. That will help you to understand the overall quality of a data.
We'll understand the hands-on of column data profiling, which is part of the data completeness check. So when do we do this data profiling? So these are essential when we are testing large amounts of data or millions of data in the project. So it is a validation to compare source and target data without actually comparing the entire data. So what do we do? So we create logical sets of data that reduce the record count and then do the comparison between source and target. And this column data profiling is also essential when we have the source and target in the different systems. For example, we should do the validation in the separate system for the source and the validation of the target in the separate system. In this column data profiling, the first check which we are going to understand is data type analysis. The second, value distribution. The third, null and missing value assessment. Next, we have statistical summary. So all this contribute to the column data profiling checks. We'll get started with the first one. To see the data type analysis, in this, we evaluate whether the values in each column match with the expected data type. Let me check the data type analysis by giving this describe table name. I got the details of the particular table employee data source. So here it is telling I have some 9 columns and their data types. So all are matching with my mapping document, and whether they are null, whether they have default values, which is the primary key, any unique keys assigned, and all other information are available when we run this describe table employee data source. So in this, we have to match with the mapping document and verify whether all the data types are correctly defined in the table. So let me check similar way for the target table as well. So I have described table, target. Let me see whether all the data types column names are matching with the mapping document. Yes, we have to deeply go through all the column names and their data types, whether they are matching with the mapping document. So this is a data type analysis check. In value distribution, we analyze the frequency of unique values, some patterns, and some ranges in the column. So let us have some count of distinct values in each column, so which will tell us the frequency of unique values in the particular column. Let me check what is the frequency of occurrences of all these columns. So in this query, we are going to check count of distinct names available in this particular column, count of distinct phone numbers which are available in this phone number column, and count of distinct email entries which are available in the email column, and the count of distinct salaries which are available in the salary column. Let me run this. So it is telling the unique names in the names column is 8. That means another 3 are duplicates. Then unique phone numbers are 11. So there is no duplicates in this particular column. And next we have unique emails. So it is 11. So there is no duplicate values here as well in the emails. And the unique salaries is 7. So there are some duplicate salary entries in the salary columns. Similar way, let me check it for the target table and see whether they both are matching. So instead of source, I have a TGT table here. So let me run this. So here as well, I have unique names 8, phone numbers 11, unique emails 11, unique salaries 7. So let me check any differences between these two. Let me have union all for this. Let me run this. So here I can compare. This is a source table output. This is a target table output. So unique names are same between the source and target. So there is no difference in the source and target tables with respect to the count of unique values. Unique phone numbers are also same, unique emails, unique salaries. So there is no difference in the value distributions in the columns name, phone number, email, salary between source and target. So the next check is, we have seen the count of distinct values here. Let me check occurrences of each particular data in the particular column. For example, in the name column, there were some duplicates. Let me check what are the count of occurrences of name in that particular column. So for that, let me use this query. Let me run this query. So I'll tell select name, count star as frequency from employee source, group data by name and order by frequency, so that it gives me a sorted list of unique names along with their count in the table in a descending order. Let me run this. So you can see here it is giving the occurrences of each name in the particular column name. So here I have 3 entries of blank values. John appears to be twice and all others are appearing once. So similar way, let me check for the target table. Okay, if it is same, occurrences of the name. So here the blank is being replaced by unknown, that is 3 entries are there. John 2 entries, apart from that all are 1. That means it is same between the occurrences of name in the table source and the target table is same, and there is no difference in the occurrences of the particular value in that column. Similar way, we can have occurrences of phone number, occurrences of salary, and some more columns. So let me check the salary. You can have on all the columns like this. So let me check few of them. So select salary, count star as frequency from employee data source. I'm grouping by salary, order by frequency in a descending order. So I could see salary of 95,000 is repeated thrice, salary of 50,000 is repeated twice, salary of 55,000 twice, 60,000 once, 70,000 one occurrence, 75 once, and 0 occurrences once. So this way we'll come to know the occurrences of particular value in that particular column. So it should be same in the target as well. Let me check for the target table. I'm just replacing source as a target here. So you can note down somewhere and check. It is same. See, 50,000 is twice, 55 is twice, 60 is 1, 70 is 1, 75 is 1, and 0, 1. So from this, we came to know that there is no difference in the source and target table when we check about the occurrences of data in that particular columns. And nowhere we are comparing with the whole data. We are creating a logical sets of data by creating group by that particular column. and then we are checking the occurrences of that particular value in the column. So like this, you can check on other columns as well. So here I have done on the 2 columns. Next, we can go with the pattern matching in the value distribution itself. So when I see the contents of the table, let me check the content of the table. Select star from employee data source. Let me check how is the pattern in the particular columns. So let me go to check the patterns in these two, phone number and email. So there is particular pattern followed in this particular column. So it is telling we have to follow 91 hyphen before the phone numbers. So let me check this pattern whether it is valid for the phone number column, and later we can check the pattern matching whether the particular email column is taking care of the specified pattern in the table. So first let us look with the phone number column. Let me use this query. So we are telling select employee ID, name, phone number from employee data source where phone number is null. That means fetch me the phone numbers from the phone number column where there is null in that particular column. That means there is no phone number specified for that particular entry, or fetch me those phone numbers which are not like in this format, and fetch me the phone numbers which are not equal to length of 13, or fetch me the phone numbers which doesn't come in this format, that is 91 hyphen 0 to 9 numbers up to length of 10. So let me run this. So these are the entries which I fetched which are not matching the format of the phone number. So you could observe here this doesn't have 91 hyphen, this also doesn't have, this have 91 hyphen, it is there in the bracket, and then this is not in the format, and this also is not in the format because it has a special character within the 10 numbers. We had told only 0 to 9 numerals or numbers should be in the phone number section. So that means there is some problem with the phone number column. Let us check the same pattern matching whether it is done correctly in the target table. For that, let me change this source table to target table and run this. So there is one problem here that doesn't follow the format. It is in the employee ID 11. So in source, so let us see source again and target. So in source, we have some 1, 2, 3, 4, 5 entries which doesn't match the pattern which is predefined for the phone number column. And in the target, we have one entry which doesn't map with the required format for the phone number column. So next one, we have finished on the phone number column. So let us check on the email column whether it confronts to the predefined format. So let us check how is the data in the table. So email, it is the required format should be some ABC at some example.com. So the entries in the email column should map with this format. Let us check where they are correct format in the email column. For that, let us write this query. So here I am telling select employee ID, name, email from the particular table where email is null. That means where email is not given or not specified. Or please fetch me the emails where email is not like in this particular format. Let me run this. So I have two emails which doesn't confront to the predefined format of the email in the email column. Those are employee ID 4 and 6. So let me check similarly for the target table if there are any errors in the email column with respect to the format of the email. So let me change this to target table. So I could see there is one entry with the wrong format in the target table as well. So we have done with the value distribution check. Next, null and missing value assessment. In null and missing value assessment, we'll measure the proportion of null or missing values, helping to determine the data completeness in the particular table. So for that, let me run this query. So I'm just selecting star from the table where the name columns are empty values. Let me see how many empty values are there. So it's telling there are some 3 empty values in the name column. So next, you can just see count star to know how many empty values are there. I'm just adding count and checking. So it is giving me 3 empty values are there in the name column. Similarly, you can check for the other columns as well. So the next column I can check is, I can check for phone number column. So it is telling there is no empty values in the phone number column. Let me check for the salary column. So why it is giving error? Because salary is a integer data type in which the empty values cannot be inserted. Instead, it will be 0. If you try to insert the empty values, it will be 0. That's why it is giving error here. So I can check on the other columns. So which are the other columns? Let me see what are the columns in my table. So I can check with the age column, grade, where age is equals to. Let me check if any empty values are there in this particular column. So age is also integer type. I'm sorry for that. So next we can check on the grade column. There's no empty values in the grade column. Similar way, you can check on the all the non-numerical columns to check whether they have empty values. So next I can check the count of nulls in each column. So let me check where name is null. Let me check the occurrences of null in the particular table. There is no null in the name column. Let me check in the grade column. Is there any nulls in the grade column? No. Let me check in the other columns. I'll check salary column. There are no nulls. Let me see what are the other columns. So I could find only the empty values. I could not find any null values in the columns of the table. Similar way, I can check on the target tables whether the name column has null. No, it doesn't have. Let me check for other columns in the target table. Similar way, you can check for the all the columns by giving this query for source and target tables. From this, we'll measure the null or missing values to determine data completeness in the table. So we can move on to the next section, statistical summary check. So in this, let me check the average value of the salary column from the table source. I'm telling, please take the entries where salary is not null. Let me run this. So the average is somewhere around 63636 point something. So let me check the similar way for the target table. It should be same, right? If there is no error between source and target, this average value will be same between the source and target. So it is same. That means there is no error in the salary column with respect to average. So let me check with the median value of the particular column salary in the table. So it is not compulsory to check on the salary column. Any numeric columns you can check from the source table, corresponding numerical column with the target table. So next we'll have median check. So median is the value that separates the lower 50% and the upper 50% of salaries. That means it will divide the data 50% down and up and then computes the exact median. Let us check the median of the salary. So I'm using prox percentile function to check the median here, which gives the median for me. So the median, it is telling 60,000. The similar way, let me check for the target table. So if data is not moved correctly to the target, there will be difference in this as well. So remember it is 60,000 here, and the target also 60,000. That means median values are also same between the source and target. So there is no difference in the data moved from salary column from source to target table. So next, we can check the standard deviation of the salary column from source and target. So standard deviation measures how much salaries or the entries deviate from the average salary or the average values, whichever you consider. So for that, let me run standard deviation function on the salary column. I'm telling select standard deviation of the salary column as standard deviation salary from employee data source table. Similar way, I can check for the target table as well. So it is somewhere around 27,757. So let me check for the target. It is same, right? So both source and target standard deviation is same. So there is no mismatch between the data moved from the salary column from the source to the target table. So next we can check max salary, min salary, and the range also. So first we'll see what is the max salary in the source and what is the max salary in the target table. So here max salary is 95,000. Let me check in the target table. Yes, that is same between the source and target. So next, let me check for the minimum salary in this particular source and target. Let me give the minimum function here. Minimum salary is 0. Let me check in the target table whether it is matching. Yes, of course, it is matching. So source and target data, max and min value of the salary is same. So there is no mismatch between the source and target with respect to max min values. So let me check max min range value check. So what it will do is, I'll just check max salary minus min salary. So this will calculate the range of salaries in the table. So subtracting min salary from max salary gives the salary range. That is difference between the highest and lowest salary. That means this also should be same between the source and target table. So let me check this. So the max minus min salary is 95,000 here. Let me check for the target table. This should also be same. So that data is correct with respect to source and target. Yes, it is same. So from this, we have done all these tests as a part of column data profiling, which is a validation to compare source and target data without actually comparing the entire data. And also we have created some logical sets of data which reduces the record count, and then we have compared between the source and target data. So we understood all the checks with respect to column data profiling.
As we have seen in the earlier videos, data duplicate check is a part of the data completeness check. So when we are dealing with the big data processing, duplicate records can arise from various stages, like ingestion from multiple sources and as a part of the ETL workflows. And if there are any unexpected system errors, in those cases, duplicate records may arise. But the question is, are the duplicate records good or bad? What do you think? Let us find out. What happens is, whenever you are ingesting the data from multiple sources, as you know, as a part of any data engineering project, we do collect the data from different platforms or systems. So whenever collecting the data from different platforms or systems, duplicate entries can occur due to overlapping data sets or variations in the synchronization of the data. So we are trying to understand what may cause the data duplication. So this is one of the reasons. As I said, duplicate are good or bad? They're not good. They're bad. Why are they bad? Because duplicates would lead to higher storage costs And also because there is a duplicate, the processing time also increases substantially. Apart from increased storage costs and higher processing time, duplicates also lead to inaccurate reporting, inefficiencies, inconsistencies in business processes. Let us take a simple example here. Let us say you have a data with duplicates. Okay, you have 10 records. I'm just taking this hypothetical example, 4 up to 10. Okay, let us say total number of values are 10. Now, within that, couple of them happens to be duplicate. Then, as you know, the mean would be different. Whenever you have a duplicate, it is simply introducing inaccuracy. That is the reason we have to remove the duplicates. So, in order to ensure the duplicates are removed, duplicate check will help to detect and eliminate the duplicates, which is essential to maintain the data integrity and reliability. So, if you remove the duplicate, it ensures that accuracy and trustworthiness of the data, and that in turn helps in right downstream analytics and reporting. Some of the other aspects of the data duplicate check are it ensures that primary key and unique key in individual columns or combinations of columns maintain their uniqueness. See what happens if they don't, right? It is going to be difficult to join the tables. There'll be inaccuracies. So duplicate check ensures primary key and unique key are unique. And duplicate check is a critical process in validating the integrity and quality of the data within a system. For example, let us say you are talking about employees or you're talking about students. So you may have employees with the same name. So then how do you ensure there is a uniqueness? By bringing in another dimension or another column. Okay. Combination of phone number and name would give the uniqueness. That is how you ensure there is no duplicacy.
For this, we'll get started. So I have a database testing. So I'll use that database testing. So to experience the data duplication check, I need some tables to be created. Let me create a table called insurance claims. So in which I have 9 columns: claim ID, policy ID, customer ID, customer phone, claim amount, claim type, claim status, incident date, settlement date. So let me create this table. Let me insert some data into this table. I'm inserting the data for the table insurance claims. Number of rows inserted, it is showing 14. So let me check how is the data in my table. Let me give select star from insurance claims. So this is how my data is there in the table. Now let me check if any of these columns are duplicates. First, check with the customer ID column and see if any duplicates occur in this particular column. So for this, I just run this query. I'm just telling please select customer ID and count star as a duplicate count from the table insurance claim by grouping all the customer ID and having count greater than 1 so that I get any duplicates if they occur. So having count star greater than 1 filters only those customer ID values that appears more than once, indicating duplicates. So let us run this. So the output it is showing the customer ID 203 and 208 appears twice in the table. That means it is telling there is a duplicate entry in the customer ID. But can we decide on one particular column and tell that this is a duplicate? No, right? For this particular column customer ID, there is a duplicate. But we have to see whether the combination of all columns are duplicate. So for that, let us check the combination of some 2 columns first and then check on combination of all the columns whether they are duplicate so that they can be removed from the table. Because customer ID duplicate means one customer can have multiple claims and multiple policies. So that's why we can't decide only the customer duplicates can be the whole duplicate data in the table. So let us go checking on combination of 2 columns for the duplicate. So here I'm checking combination of customer ID and policy ID, whether there is a duplicate in this combination of customer ID and policy ID in the table insurance claim. So for that, I'm grouping by 2 columns and then having count star greater than 1. That means it filters only those combination of customer ID and policy ID values that appear more than once, indicating duplicates. So let us run this and see customer ID, there is a duplicate, and policy ID also there is a duplicate. So with this, we can check other combination of columns are duplicate as well. Then we can decide whether this customer ID and combination of this customer ID and policy ID is duplicate across all the columns. In case if all the customer ID, policy ID, customer phone, claim amount, claim type, claim status, and other columns also shows duplicate, then this is confirmed that there is a duplicate entry in the table. So for that, what we'll do is we'll go with the next query, like combination of all columns. So this is a combination of all the columns which I'm taking in a select query, grouping by all the columns and then telling count star greater than 1, so that it filters only the duplicate entries across all the columns. Let us run this and see. So here it gives customer ID with 208 is a duplicate entry across all the columns. If you observe 208 customer ID, policy number is 5008, that is also duplicated, phone number as well as all these columns are duplicated. But when we had run this query for the customer ID, we had got duplicates 2 customer ID, right? See, we had 203 and 208, but for now we came to know 208 has a duplicate across all the columns. So let's see why this 203 customer ID is not considered as a duplicate. So for that, what we'll do is, we'll just tell select star from insurance claim, that is a table name where customer ID in 203 and 208. So which gives details of only those customer IDs 203 and 208. So let us run this. So if you observe here, see customer ID is 203, 203, right? But the policy IDs are different here. If you observe, customer ID is same, but policy IDs are different and claim IDs as well are different. That's why it is not considered as a duplicate entry in the table. But in this case, where customer ID is 208, 208, policy ID is also a duplicate, phone number is also a duplicate, claim amount is also a duplicate. All the columns are duplicated with respect to customer ID 208. But this claim ID is different. Maybe that is wrongly entered in the database. That is why when it gives combination of all the columns are duplicate, it is considered as a duplicate entry and it should be removed from the table to maintain the data integrity. I hope you all understood how data duplicate check validation is done.
We understood data accuracy check is a part of quality, right? Data accuracy check is a part of the data quality. What exactly is a data accuracy check? Why do we do it? Let us understand that. As a part of the big data testing, data accuracy ensures that the data values match the source, and it also ensures that the formats which are mentioned in a mapping document is same, and whether the data is precise or not, like it has to be $20,000. Is it more than that or less than that? Data should fall within expected ranges and align with the business's rules upon reaching the target systems. So all in all, it ensures that data values match the source, formats are proper, there is a precision, and the data falls within ranges, and all the business rules are taken care. That is what is validated by data accuracy. Now, it will verify the data values are within acceptable ranges. It ensures that data is precisely loaded. It ensures that data is accurately loaded and transformed as expected, as mentioned in the mapping document. The data should not be misspelled or inaccurate, should not be null when it is supposed to have values. For example, here in this case, we'll see this is invalid format because the name doesn't contain @ right? And minus 30. Who on the earth will have a age minus 30? And this doesn't have the proper email ID. Like this, all these aspects are checked during analysis of accuracy check. In data accuracy check, we do have two types. One is non-numerical type analysis. The second one is domain analysis. What exactly is non-numerical analysis? In non-numerical analysis, we verify the accuracy of the non-numerical content. It is mostly, we will verify any data which is non-numerical. Can be a name, can be other aspects. So examples like emails, PIN codes, phone are validated as a part of the non-numerical values. Don't confuse the phone number being a numerical value. Phone number is a numerical value, but you will not add the phone numbers together, right? That is the reason it is classified as a non-numerical type. Then moving on to the domain analysis. In the domain analysis, we'll ensure that we'll validate the data is proper in terms of value, in terms of range, in terms of reference file. Let us take an example for each of them. So when we talk about the based on value, we'll create the list of values that can occur in that particular column in the table. For an example, gender. When we talk about the gender column, it can be a male or it can be a female. You cannot have multiple hundreds of genders, right? You can have only these two genders. So we'll validate if the column values are subset of our list. In the gender, we should have only male and female. So we'll validate if the values are subset of our list. Then based on a range. So what we'll do is in a particular column, we'll set a minimum and maximum range for the data values for a column based on the logical and business reasoning. For example, here age 0 to 125 years. Yeah, there may be a chance that people may live beyond 125 years, but it is 1 in billion chance, right? So we create a range in this particular column. The values should be between 0 to 125, and we'll validate whether the values fall within this range or not. Then moving on to the reference file. Here, what happens is we use a file, external validative file. In that file, we would have mentioned the different aspects, like are the country codes valid? Do they pick the right values from the reference file? And are the country codes the same between QA and the production environment? Like this, for the country codes, we would have created a validative file. We use that particular validative file to verify all the values in a particular column. Awesome, isn't it? We understood the data accuracy check in detail.
We'll understand data accuracy check hands-on. So data accuracy check, what does it do? It verifies the data values are within acceptable ranges. So in this check, we can find out the data that is misspelled or inaccurately recorded, null, non-unique, or out-of-range data can be found in this process. We have different types of data accuracy checks. So let us see one by one. So we have non-numerical type analysis and domain analysis. So in non-numerical type validation, it involves verifying the accuracy and correctness of non-numerical data such as emails, PIN codes, and phone numbers, etc. So here it ensures that the data conforms to a specific format or pattern, preventing issues caused by incorrect or inconsistent data. So in a way, this ensures consistency and accuracy in the data so that it prevents invalid entries from corrupting the data set. And also it helps in reducing the downstream errors caused by poorly formatted data. And also it helps in maintaining the data integrity for reporting and analysis. So let's get started. To get started, I've logged into Snowflake. Let me create some tables necessary for this data accuracy check hands-on. So I have created the database called testing. Let me use that. Use database testing. And then let me create the reference table. So my reference table here is country code reference. where I have two columns. One is country code, other is country column. Let me create this table. Okay, the table is successfully created. Let me insert some couple of values to it. So it's telling number of rows inserted are 6. So let me check how is the data here. So I'm giving select star from the table name. Okay, it has 6 rows. So let me create one more table. So one more table which I'm creating is employee. It has 3, 4, 5, 6, 7, 8, 9. 9 columns. And here I'm referencing this country code from the country code reference table. The table is successfully created. Let me insert some values. Okay, I'll insert some valid and some invalid values so that I can experience the errors as well when I validate. Okay, telling some 11 records are inserted. So let me check the data from the table employee. Yes, I have 11 rows inserted into the employee table. So firstly, I would like to validate the phone number column. We have phone number column here. So in non-numerical type, to check the format, I'll just check this format of the phone number, whether everything is valid or any missing phone numbers are there or any invalid record or invalid format in the phone number exists. Okay. So let me run this query. We have seen this as part of completeness check as well. So here what I'm trying to do is I'm selecting the two columns, that is employee ID and the phone number column from the table employee. I'm using the regular expression. So I'm telling where phone number is not falls under this format. Okay. So regular expression is used for regular expression matching. Okay. We'll decode this. This symbol, it indicates start of the string. Then I'm telling please allow 1 to 3 digits of the country code, and that country code should involve the numbers ranging from 0 to 9, and then match the hyphen after the country code. Then I'm telling, after matching the hyphen, I'm telling again the phone number should be 10 digits. Please validate 10 digits of the phone number should be from 0 to 9 numbers, and then this is the end of the string. So I'm telling whichever doesn't fall under this format, please fetch me those data from the phone number column. Okay, let me run this query. Yes, so I got some 3 entries which doesn't follow this format. That is a valid phone number format. In the table I have country code hyphen the phone number. So all these 3 entries, employee ID 4, 8, 9, doesn't match the valid format according to the requirement. So I can raise this as errors. Okay. So next comes domain analysis check. Okay. So in this, based on value, we validate, and based on range, we validate, and based on reference file also, we validate. Okay. So let us get started with this based on values. So we'll be given a list of values that can occur for a particular column in a table. So in this process, we'll validate if the column values are a subset of that list only, or else they are considered as errors. So let us take an example here of let me show you all the columns first. So what I can consider this grade column. So the list of values given for us in the grade column, they're telling it only includes grade A, B, and C. So this is the list of values given to us. So whatever the grade values are there in this particular column should fall within these values A, B, C. Apart from this, if anything else exists in the table, then it will be considered as errors. Then, so next we'll get into domain analysis based on range. So here some maximum and minimum value range will be given for us. So based on logical and or business reasoning, we should validate if the column values fall within a range. If not, they are considered as error. So in this table, they have given the range for age column. They are telling the range is greater than 0 and less than 120. Okay. So next we have reference file. For this we have taken example of this location and the country code in the phone number. This country code should come from the reference file. So let me check this table. Let me give select star from country code reference. So whatever the codes are there in this table should be given as a code for the phone number in the employee phone number column. So I have to verify whether these are valid codes with respect to the reference table country code reference. Okay, so let us look into domain analysis check for the validation of list of values given for the grade column. They have given the example of grade column. So we have to check whether the grade column only consists A, B, C grade. Apart from this will be considered as a error. So we'll run this query. So select start from employee where grade not in this A, B, C categories. Okay. So let me run this. So I could see there is only one employee ID with 9 which has a grade G which is not in our list. Okay. So this can be considered as error here. The next we have domain analysis depending on the range. Here the range we are checking for the age column. So for that, let us run this query. Okay, so I'm just telling select employee ID, name, age from employee. So I'm fetching if any of the entries are there less than 0 and greater than 120. Let me run this query. So if I have any age values other than the range given to us will be displayed here. So we have employee ID 6 with the age of 150 which is greater than 120, and we have age of employee ID Sophia as minus 50, as this could be like mistyped, misentered in the table. So this will be reported as a error, that telling that it is not in the valid range. So we saw range. The next is reference file or table. So we have to check whether they are picking up the right value from the reference file. So here main table is employee. So I have to check whether it has picked up the right values from this country code reference table. So for that, I'll use this query. Okay. So what I'm doing is I'm selecting employee ID, phone number, location from employee table. I'm joining with country code reference using left join. The substring will extract the country code from the phone number column. How it is doing? So it extracts the characters starting at position 1 up to the position before the hyphen. So here the position returns the numeric position of the hyphen in the phone number. Then the extracted substring is matched with the country code column in the country code reference table. So here what does it do is it fetches all the matching data. So then we'll have where condition. So this where condition, what does it do? It filters out only the records where the left join did not match with the country code reference table. So this means the extracted country code from the phone number does not exist in the country code reference table. We are just taking the mismatch entries, not the matched entries. So that will report only the errors. Okay, when we run this, there are two phone numbers with an invalid country code. Okay, so this check ensures that there is a problem in fetching the country code with the phone number in the employee table, the reference table, country code reference. From the reference file, we can also validate whether the data is being correctly loaded in this particular or in whichever reference loaded in the phone number column. And also we verify the country codes are valid. Do they pick the right value from the reference file? And also the country codes are same between the different environments. Example, QA and the production environment, etc. So that's it with the data accuracy checks. I hope you understood the data accuracy check. We had non-numerical analysis as well as domain analysis. Thank you.
That's all for now. Like and subscribe and turn on notifications for future videos. Thank you.